Hi, and welcome to Gaming with EaselJS, an advanced canvas course on Tuts Plus. In this lesson we're going to take a look at our game camera. Now, calling it game camera is not exactly accurate. Obviously the problem we have is that our hero can travel anywhere within the game coordinates, but our stage just sort of stays fixed on this area here. So we can quite easily lose our hero and then we'd have no way of getting him back. What we really want is for our canvas point of view to follow the hero around. To do that, we need to move the entire canvas stage in the opposite direction that we're traveling. So what I call camera is really just moving the entire world coordinates around opposite to where the hero is so that we can always see the hero. I've drawn up a graphic that might help explain it in a little more detail. So if we take a look at these values here, I've made Y and X represent the screen height and the screen width. This, in our case, is our canvas width and height. This is the level width and height here. So when the player is within 1/2 of the screen width and height from the edge of the level boundary, we don't want to follow it anymore. If the hero were in this section, which is more than half of the screen width and less than half of the screen width from the other side, then we want to follow his X position, but not his Y. And conversely here, if it's in this section, we'll follow Y, and if it's in the middle, we'll follow both X and Y. So this is how I visualized the logic in a graphic, but now we have to turn this logic into code. So let's get started. Open up your terminal and start the grunt task, and then open up your Tuts Canvas project folder. If you open up main.js, rather than just updating the stage on each tick, we're also going to be moving our camera. Now the first thing we're going to need to do is get hold of some value. If you remember, we needed the width of the canvas and the height of the canvas, and we'll also need the height and width of our world. We'll be using this half Y and half X value a lot, so we'll also create a variable for the center of our screen. So for now I'm just going to hard code these values in. _W and _H are going to be the width and height of our canvas. Our center positions, X center will be W divided by 2, will be width divided by 2, and Y center will be H divided by 2. Next we need to know our world width and height. At this point we haven't really designed or set up levels or our world in any way, so we're just going to hard code a value for now. Later on, when we actually build a world from some level data, we'll be able to set this value once we create the world. So the first thing we can do is check if our world width is actually greater than our screen width. If it's not, then we don't need to do anything. If it is, we can check firstly if our hero is in this space here in terms of X position. He has to be greater than 1/2 of the screen away from the left side and more than 1/2 of the screen away from the right side. So if hero.x is less than the world width minus half of the screen width, and the X position is greater than half of the screen width, then we want to set our world X position to minus the hero X position plus the center distance. Else, if the hero is in this area here, then we want to set our whole world position to remain so that our screen stays aligned to the right here. So if hero X is greater than or equal to world width minus half of the screen, then we'll set world X equal to minus the world width minus W. And the final else covers the situation of the hero being in this zone here, in which case we want the world position to remain at 0. So let's give that a try. So world is not defined. So what I need to do, of course, is set up this world container. World equals new c.container. We'll set the world X and Y to 0, and then rather than adding the hero to the stage, we'll add him to the world, and of course the world should be added to the stage. We'll just have to expose this world variable up here. And let's just make sure that our world is being correctly added here and our hero is being added to the world. So as you can see, our hero, now when we get to the middle of the canvas, it looks like the hero is not moving anymore. This is because the world is now moving in the opposite direction as the hero at the same pace. If we want the same thing for the vertical position of the hero, we'll just need to do the same thing again. Now, while these two pieces of code obviously look very similar, I've tried on multiple occasions to refactor them so that it's essentially the same function, just manipulating different values. It always ends up being pretty messy though, and actually a lot less readable than just leaving it like this. So now we get the same thing going up and down, and when we're in the middle it looks like our hero is not moving at all. It's about time that we got some design for our hero and some imagery in the background so that we can actually see that our hero is moving. I went onto Open Game Art and downloaded a sprite package called Space Shooter Redux. As you can see, it's free for any sort of usage, and it's got quite some nice little graphics for us to get started on a game. I'm going to get two images from this and pop them in here. One is our hero, and the other image is a blue starry background. Open up your hero class and go down to our prepare body function. This time, rather than creating a shape for our body, we're creating a new create.js bitmap, passing in the path to the hero PNG. We'll then position the bitmap relative to our hero container and add this to the hero, which, if you remember, extends from container. And so here is our hero. Now it's time to put a nice background on here. Something that's cool with working with Canvas is that we're free to use any web technologies, and that includes humble CSS. We don't have to create an extra sprite to give our game a background. We can actually do it with CSS. Open up your main CSS, and rather than having a background color white, we'll set it to image blue PNG. So there you have it, a blue starry background. But it looks pretty static, it's not really moving. Let's see if we can remedy that. In our main.js file, after we've set the camera position, or our world position technically, we can update our background. Now once again, we don't need to do anything special with Canvas to change this background. We can actually do it with plain old CSS. We just need to get access to the Canvas element. Let's create a reference here, and then when we get our stage prepared, we'll set canvas equal to stage canvas. Then when we update the background, all we need to do is get our X and Y position of the world and set our canvas.style.background position X and background position Y equal to those values. So now when I fly around, you can see that it looks like the background is moving relative to the spaceship. When we get to the confines of the level, or what we've defined as the confines, the animation stops. Before we go, let's just make our world a little bigger. We'll change this value here to 700, and in the HTML we'll change our canvas to 700 as well. We'll also just change the width and height in CSS here to 700. Now you'll see that hasn't actually updated the project. This is because our grunt file is not watching CSS files for changes. If I add app/css star.css and restart the grunt task, then when I change these values, make that 700 and this should be 350, you'll see our project automatically updates. So that's all for this lesson. As you can see, we already have our hero set up and flying around in space. Check back in for the next lesson, where we'll be setting up a collision manager so that we can start putting in some obstacles for our hero to avoid. Ciao!